Welcome to Food Safety 5, twice monthly reports from the Food Safety Magazine editorial desk to keep you abreast of top news stories and current events impacting the food safety sector. This episode, we're covering 3 recent studies that shed light on microbial risks and technological advancements in food safety. First, a new study from the Spanish Higher Council for Scientific Research and the University of Cordoba found that cross-contamination of food by multi-species biofilms can increase Listeria monocytogenes growth in ready-to-eat foods. The researchers formed multi-species and single-species biofilms using bacteria taken from surfaces in food processing environments and grew them under conditions mirroring the real world. They tracked L monocytogenes transfer rates between smoked salmon slices and the biofilms, and they measured the growth of L monocytogenes over time on the salmon samples. Compared to L monocytogenes from single-species biofilms, pathogen growth associated with multi-species biofilms was significantly greater during refrigerated storage. This is especially relevant in light of recent amendments to EU regulations on L monocytogenes in ready-to-eat foods, as the researchers demonstrated that the L monocytogenes load in samples contaminated from multi-species biofilm exceeded the regulatory limit after 15 days of cold storage. The findings underscore the importance of considering multi-species biofilm contamination when designing challenge studies, facilitating more effective L monocytogenes control. In another study led by the University of South Australia, researchers developed an AI-powered method for real-time detection of mycotoxins in food products. Using hyperspectral imaging and machine learning algorithms, the system was able to identify contamination with high accuracy across various food matrices. Additionally, when the researchers reviewed more than 80 studies on mycotoxin detection methods, they concluded that machine learning integrated hyperspectral imaging consistently outperformed conventional mycotoxin detection methods. The technology could offer a scalable, more rapid, non-invasive alternative to traditional mycotoxin testing. The researchers are currently optimizing the technology with deep learning and AI. Finally, a study led by the University of Georgia's Center for Food Safety found that seafood imports may spread resistance to last resort antibiotics throughout the U.S. food supply. The team purchased imported and domestic shrimp and scallops at retail and tested bacterial isolates for susceptibility to colistin, a critical last resort antibiotic in human medicine. Colistin-resistant colonies were found in 20% of imported samples, originating from China, Indonesia, and Thailand. Further polymerase chain reaction and whole genome sequencing analysis revealed that the isolates were capable of horizontal gene transfer, biofilm persistence, and functional resistance expression. Based on their findings, the researchers underlined the risk of rising antimicrobial resistance facilitated by the global food trade. For more information on any of the stories mentioned in this video, be sure to check out the Food Safety Magazine coverage linked in the description. Check back twice monthly on Tuesdays for the latest Food Safety 5 episodes, available at food-safety.com or on our YouTube channel.